According to Leon Battista Alberti, the modern paradigm of architecture relies on an idea composed in the mind that becomes translated into a standard code of orthographic drawings. This provides enough information for its manifestation. This notion, known as Alberti's paradigm, separates the architect from the master builder, placing the architect as the sole author of the work. The digital age has turned this top-down approach onto its side as new technologies have presented novel means of representation and production. As other parties have suddenly gained influence in the design, the architect's agency has been challenged and Alberti's top-down, direct approach eradicated. As a result, the introduction of a neural network agent, or AI, into the practice poses the question of what this means to architects and their agency. While many may fear a fully automated AI system will replace architects completely, this thesis proposes a collaborative approach instead, where architects embrace AI applications to generate architecture design. More importantly, these AI applications enable architects a way to conceive their intentions through visual abstraction, prototype reconstruction, and comprehensive sensibility at a much higher level than earlier, overriding Alberti's mind-to-orthographic drawing approach.
In this study, we started with exploring the traditional form-finding cases, which is the branching pattern or also called dendriform. The concept of dendriform is a source of architectural design inspiration with different approaches undertaken by architects at different times. Tree-like patterns have been related to architecture since prehistoric time. Architects and constructors apply this self-similarity as a way to improve and optimize their structural and architectural solutions. In the new time of AI working with architects and artists, we question does AI become capable of numerous form-finding process? After looking into different forms of artworks, we finally used the artwork from Ivan Generalik as our initial design feeling.
This exploration was initialized by neural style transfer, an optimization technique which merges a content image and a style reference image to output a 2D image result, which maintains the content but downs the style of the style reference image. This AI application of using a convolutional network presents an evident moment of the designer's sensibilities, the selected images, and the deep learning ability of an AI working together to initiate a project. An initial style transfer of a 2D image of a vertical geometry was merged with the style reference of a painting by Croatian artist Ivan Generlik. The result generated two discernible masses adjacent to either side of the geometry, connected with branch-like elements and transformed onto the initial geometry and its surrounding space.
Basically, we started from Google Deep Style, use style image to transfer the image of building elements, use the feedback from the style transfer image to change the building elements image and the style image to get what we want. After we get what we want, we extract the main features out and generate the style transfer geometry and model from 2D to 3D. The result of 3D model generating also gives us information to help us decide what kinds of feature we need to extract. The whole process is a way of collaboration between human and AI. So at the beginning, we built several simple volumes in Rhino with floors and ceilings. One hard thing in our proposal is how to transfer 2D image to 3D model. Our approach is to use building sections to extrude and generate the models. Firstly, we cut the model with two cutting planes and divide the model into 4 parts. Then we got 2 simple sections. After that, we use Google Deep Style to style transfer these 2 sections. Then we extract and trace the main features of the style transfer images. Based on the feature drawings, we extrude the 4 parts of the model out. And we combine all of them together to get the final 3D spatialized style transfer model, which is a weird but interesting structure full of branches. However, the model couldn't stand by itself. It doesn't have any structure to support it. So we use the same method to generate columns, from the simple column sections to style transfer images to the branching feature drawing. We use the two branching feature drawings to generate different types of columns and place these similar but slightly different columns inside the structure evenly. These columns are not only used for the structural purposes, but also are the spatial elements inside the branching structure. Here's our model that combines the original volumes and the style transfer structure and the columns together. We want to show how AI can inspire the design of architecture in the new age, and how humans can make the new design more accessible, workable, and habitable. This is our final model. We added a layer of glazing into the model. The whole design is a collaboration of human and AI, architecture and technology, the simple and the detailed. Our site is in Xiong'an based on Chinese Academy of Engineering estimation. The target population in 2040 for Xiong'an is 2 to 3 million residents, including locals and millions of employees in industrial industry. So for now, providing high-quality social services for potentially millions of newcomers is a great challenge. So we propose a community center in the center of a startup area in Xiong'an. Most of the surrounding areas can go to the community center within 30 minutes walking distance. The site is also located alongside the landscape belt and is also within an efficient road system. For the future image, the community center is surrounded by many residential buildings and office buildings. During the residents' and workers' free time, they have convenient access to the community center to work out, drink coffee, make friends, etc. At the same time, they can enjoy the river view to relax themselves from daily heavy work.
Let's move forward to our phase 3, the architecture session. As we said before, this community center serves as the agency between AI and architects, which in this case questions us how to collaborate the original building programming within the new system. As a community center, this building is programmed with gyms, sport courts, WeWork and WeStudy spaces. The branches translated from Google Deep Style serve as the center flexible working out slabs. This community center is a 3-story building with 1-story basement. Here is the first floor plan. It provides the fitness room, badminton court, WeWork space, and convenience store. This is the mezzanine floor plan. It is used for staffs who work here. The second floor is basically similar to the first floor, but now we could see how the branching structure is getting intricate and overlaid. Finally, to the third floor, by tweaking the branching to the images, we could create a natural generative branching platform, and it is a basketball court in this case. Here, the first section. In the section, as you can see, there are 3 elements here. They are the branching structure, the main volume frames, and the glazing enclosure. This drawing helps to call out some programs I showed to you before, like the fitness room and the basketball court. And here is another section view, similar with the previous one. And if you could notice that the branching there is finer compared with the main structure, that is because the initial image resolution and scale we choose are different in the design phase. Inspired by the vertical branching structure, we also include the climbing wall and the climbing structure in this community center to create an interesting, dynamic, and a little bit challengeable area for the climbers. In order to create the frameless transparent building facade, we use the structural glass system in this case for both the facade and the roof. A picture here shows how the building facade looks like from the WeWork side. Some more pictures to show how the entrance look like and how these branching elements grew from each other. The last hallucination is about how we utilize the branching structure as the covering ceiling for the mechanical infrastructure, where again, shows how designers rethink the design process after getting feedback from AI. This brings us to the end of our presentation. Starting with the emerging AI technology and how it's going to change the conventional out-with-this paradigm in architectural drawings, we rethink the opportunity created by AI in the realm of architectural form-finding process. Meanwhile, designers are also processing the feedback information from AI to strengthen or modify their initial design sensibilities. The conversation between AI and architect finally turns into the collaborative agency with new solutions, creative design, and updates for our discipline. Thanks for your listening, and now I would be happy to answer any questions you may have here.